Okay, this is that video that I tried to post 2 weeks ago that had no sound. So this is a redo of that video. So we're going to talk about a little bit about stats, a little bit about data science, a little about empiricism, and a little bit about me, your instructor, Jake Patton, PhD. This isn't anything you need for the exam. This is the kind of thing where you watch it to get a big overview of the kinds of things that you're going to be able to do at the end of the class. Like where stats are used, why they're good, the career of data science and being a data scientist, and then also empiricism, which really goes hand in hand with statistics, biostatistics, data science, all that. You can't really have one without the other. You have to have empiricism to have data science. Okay. Next. Oh, I will briefly explain to you what the hell's going on down here at the bottom of the of the screen. So let me. One thing that we're going to need here, I think, is probably my laser pointer. There we go. So this is derived from a talk that I gave to a legal empiricism group at U of A, and the talk focused on music, beer, and crime, and we are still going to talk about music and beer. Actually, we're going to talk about music and beer through the entire class, and you actually know this at this point, but we talk about music because of Al-Kindi. He was the first person to use central tendency. First recorded person to use central tendency, I should say. He was also a musician. Beer comes into it actually in several cases, but most obviously from William Seeley Gossett, who was the head brewmaster at the Guinness factory and who developed the t-test to decide if he was using a barley that produced a significantly higher yield than a different strain of barley. So he, used it to make more beer. Totally cool with that. And then lastly, I talked about crime. We probably don't have time to talk about my crime research in this video, but I can link you to another one if you want to look at that. Okay, so let's go. So a little bit about me first. We'll get the boring stuff out of the way really quickly. I was born here in Mesa, in Arizona, at the hospital with the little porthole windows that you can see from the freeway. I graduated from Hamilton in Chandler. I was one of the only poor kids that went there. Then I went to ASU and got all the rest of my degrees, my BS, my MA. So the Bachelor of Science was in psychology. The MA was in cognitive psychology, and then the PhD is also in cognitive psychology. And while I was there, I specialized in auditory and visual perception. Those are like kind of subfields of cognitive psychology. And so the specialization in auditory perception is actually what brought me to the College of Health Solutions, where my main job is teaching in the speech and hearing faculty. I'm one of the speech and hearing faculty. I totally couldn't think of what our area was called for a second there. So I'm one of the speech and hearing faculty, even though right now I'm teaching in biostats with all of you. And I am a runner. And this was after a mud run. I'm not the one in the front, obviously. That guy is a different guy. Okay. So I also want to talk quickly about my research. So this is cool stuff. Less boring to you probably than the last slide. So some of the stuff that I've done, one of the coolest ones, I don't know, they're all pretty cool. How can I say one of the coolest ones? These are the three coolest things that I've done so far, I think. So I've looked at swear word usage, and that's this graph here at the top right. We're looking at swear words. And now that you've taken a couple classes with me, you know that swear words are definitely things that I will use. So I also wanted to just investigate them. What you're seeing here is the dark bar is a proportion of usage of a phoneme in all of these different types of phonemes. So the dark bar is swear words. The light bar is typical words, just usual words, non-swear words. You can see that, for some things like swear words and typical words don't differ a whole lot. There's not a whole lot of difference. And then there is a lot of difference for some things, like There is a lot more swear words that use the sound than regular words. Is an interesting one, because I bet you can think of one really popular phrase that uses two uhs in a row, and a couple ers as well. And you're thinking like, well, it's interesting that it's not higher on the scale. Well, this is pushed by two things. So the here is pushed by two things in non-swear word usage. It's something called a schwa. So I don't think any of you are from speech and hearing, and that's okay. If you are, though, you know that the schwa is our unstressed sound. So when you say something like information, that shun has an sound in it. That's the schwa. It's the unstressed kind of default sound. But the other thing that's in this graph for is one is the schwa, and the other one is like an that you're actually intending to say. So like butt, like the butt of a cigarette, or cut, or something like that. Those are not a schwa. Those are an and so this graph is actually taking into account both uhs and schwas. When you get rid of schwa and you just look at purposeful then the swear words totally take over. And so the swear words kind of take over the and the and then there's another interesting thing going on. And oo. Where's oo? Where did it go? Ooh, there we go. Ooh. No swear words use ooh. Interestingly, no swear words use and over here. There's a lot more words in typical usage than there is for swear words. And if you think about that, that goes along with like, what do you do when you talk to your dog or a kid, or you're trying to cutify anything, is you say like ooh and It's this kind of like parentese language. Like we'll say like, honestly cannot think of doggy, right? You put an at the end of it. So stuff like that. You kind of like cutify these things with these phrases, and you don't usually use an and an So we think that what's going on here is that the words that have ended up becoming swear words are the ones that had these sounds in them already. If you trace back some of the like cream of the crop swear words, we're talking the ones that'll make things rated R and the ones that'll make things rated PG-13, two of the best words that you can think of. They did not start out as swear words. So one started out as a term just for intercourse, and the other started out as a term actually just like a clinical term for diarrhea. And so then as they filtered down through the language, they became vulgar. They didn't start vulgar. We think that the reason why these words became vulgar is just because they had the right sound to them. They already sounded a little vulgar, so they became more vulgar over time. And then other words, say like poop, became not vulgar at all. Originally, that word wasn't a swear word either. It actually meant like to play a trumpet. It was the sound that a trumpet would make. So you can kind of trace in a sort of roundabout way how it came to mean excrement. Anyway, it's totally like the kid version of excrement now. It used to be like toot. I mean, like toot is not a word that we use anymore either. Like when you're like playing like toot your own horn, like that kind of thing. That used to be equivalent to where it was. In fact, toot and poop share the same ancestor. Anyway, definitely didn't have anything to do with excrement, but became like the kid term for excrement, possibly also through the same thing. They're like, well, it sounds totally acceptable, and maybe we'll just use it in that way. Anyway, we're doing more research on this with different languages. We've looked at German, we've looked at Spanish. The problem with that is English is a Germanic language, so it's kind of not surprising that German and English would share a similar graph, and they do. Spanish sort of shares a similar graph, although if you're a Spanish speaker, you know that you do not have as many vowels as English. You have 5. Maybe 6 or 7, depending on who's really slicing them up. But the common agreed upon is 5. It's more like there's five vowels, and there's like 2 flavors of 2 of those other kinds of vowels. Anyway, there's just not enough. There's not enough degrees of freedom for us to be able to see what's going on with Spanish. Degrees of freedom is a term that you'll get more acquainted with through the course of this class. So one thing that we want to look at is Welsh. Welsh has like 24 different vowels, so that's definitely something that has a lot of degrees of freedom we want to look at. We also want to look at something that's not in the same language family. So Spanish, German, English, and in a way Welsh are all part of the same Proto-Indo-European language family. We want to look at things that are not in that. So we'd like to look at things like Yoruba, which is what they speak in Nigeria, and also Chinese. So that's something that we're working on right now. Speaking of Yoruba and Nigeria, I've also worked on this project right here, looking at the Nigerian talking drum. So this guy down here is playing the talking drum. And what's cool about the talking drum is it can convey speech information. Not necessarily to somebody who doesn't speak Yoruba, the language that they speak in Nigeria. It's actually one of 3 languages they speak in Nigeria, but whatever. If you are familiar with the language, then you can make out what the drum is trying to say. And we looked at the way that this drum is actually representing speech. Like, how is it using just frequency and intensity to represent speech? How is it taking all of the characteristics of speech and turning it into a signal? The answer to that is pretty long and complicated. We kind of figured out an answer for it. There's probably more that we or someone else will do eventually to figure out more about how it encapsulates that. If you're curious, you can ask me about it, but most of you would probably just be bored by the answer. And then lastly, I'm working with a group to discover the secrets of tetrachromacy. And tetrachromacy just means that there are people who have 4 color cones in their eyes instead of 3. And you can imagine that what this means is, if you think that people who are colorblind only have 2 cones, usually, sometimes you can have people with 1, but most colorblind people only have 2 cones, and they see far less colors than those of us with 3, then these people with 4 cones are way dealing with something that we can't even conceptualize. So many more colors. We think that we've figured out a way to tell who is a tetrachromat, and if we can figure out who's a tetrachromat, then we can develop a test to identify more tetrachromats. And then from there, we can see if there's any sort of benefit. One of the things, this is a picture from Psychology Today. I was in this magazine for my research with tetrachromacy. One of the things, this was really early on, I think this was in January of last year, thinking that we could possibly identify contagions with the colors that people with tetrachromacy can see. So maybe like coronavirus or other things. There's some research to back this up, that some people can detect illness in people just by looking at them. It's kind of noisy, obviously, because it's not like you can be like, that guy's sick. But there's some people can see a little bit of a color difference, and maybe people who have tetrachromacy can see more of a color difference. So anyway, that's what we're working on right now. Okay. So let's talk about who I am statistically. Like, how am I qualified to teach this class to you? So I've taught research design and statistics for 6 years. So all throughout graduate school, I've been teaching research design and statistics. I've been a researcher and statistician with the SAMBA think tank at ASU. That stands for the Science of Art, Music, and Brain Activity. So, cool things like art and music, and then also really high-tech things like fMRI, EEG, and other things like that. So we're kind of looking at how the brain works, how we enjoy things like art and music, etc. Obviously, not all of them are involved at all steps. We're not always doing brain imaging. We're not always looking at art, whatever. This is a seminar class, and if any of you are interested in it, you are more than free to join. You don't have to come every week. You can come whenever you want. If you want to take it as a class, you can. Let me know. And we meet on Tuesdays at 3:15. Technically 3:14 because it's pi time 3.14. It's a pretty nerdy group. I also founded Yggdrasil Data Science in 2017. This is my own data science company. I've contracted with aerospace firms to run some tests on different structural components of wings, just showing that one is statistically better than another. I've also worked with law enforcement training programs. It was really cool. It's like virtual reality law enforcement training programs. It's totally cool. And I got to play in them too, which was really fun. And then also I worked for MUFON, which was a totally weird, or I worked with MUFON on some data, I guess I should say. And that was a weird experience. Definitely the first thing that they wanted was can you prove that UFOs exist? And no, it's not that kind of data set, which is something that hopefully you'll learn through the course of this class, is that there's some things you can't just magically pull things out of your data that don't exist in the data. Your feelings on UFOs, whether you think that it's complete BS or you think that they're here and they've been here and they've taken you or whatever, those feelings aside, the data that I was working with was not something that you could pull that kind of answer out of. The data that they had were just reports from people. We saw this and this is what it looked like. So there's no way that you could prove that what they saw was real. There was no way that you could prove that they weren't lying about it. There's no way that you could prove what they saw wasn't something else, that should be in the air. So no, we couldn't prove anything about that. That's just not how that data worked. Now, there was a thing that we showed that is interesting. And again, this is a thing, I really want to present this at a conference, but I can't figure out the right conference to present it at. If I present it at a typical science conference, I think the very fact that I'm using data from MUFON might make people think that it's weird. It has nothing to do with UFOs, though. And then if I present it at a UFO conference, they would be like, you're not talking about UFOs. What are you doing? So anyway, this is what we did. Someone had the hypothesis that MUFON has a strong racial bias. And from the data that we had, I said, we can actually look at that. I mean, we can't tell you anything about UFOs, but we can totally see if there's a racial bias in the reporting, what MUFON thinks people are seeing. So in these reports, you get the reports from the person's zip code, you get what they saw, and other identifying information about them. Not super identifying, not their name or anything, but some identifying information about where they are and who they are. And then you also get MUFON's decision on what they think it was. So they will mark things as, this is probably just someone seeing an airplane or a meteor or something like that. Or they might say yes, we think this is probably a UFO sighting and this is worth further investigation. So We take the zip code of where the sightings have been, where they come from. And then we look at income, which you can pull from the large data set you can pull from the Census Bureau. So we were dealing with the income as of 2010. Although we did this work with reports from 2012 up to 2016, so it pretty valid for 2012. Things could have changed by the time we got to 2016. Anyway, so we pull income, we pull percentage white for the zip code as well. So you'll get high numbers for if there's a high percentage white, and you'll get low numbers if there's a low percentage white. Now these things range from almost 1, like almost 100% white in a zip code, to like 20% white in a zip code. This is like the range we're dealing with. So there's a big range. Income, of course, is another thing that we can deal with huge ranges, right? So you've got Beverly Hills, which is like, woo, way out of there. And then you've got these places in Missouri, which are like $12, yearly income, something crazy like that. So we have two hugely varying data sets. And we also put in what MUFON thinks that these people were seeing when they make reports to MUFON. And what we found was, if the zip code is a lower percentage white, it is more likely that the sighting was coded as these people are just mistaken. This is just an airplane. And when we correct for income, it makes it even worse. So, some of the things you might think are like, well, a lot of racial differences is really an income difference, and that's totally true. That is overall mostly true. It's more of an income disparity that we have. But in this case, when you're looking at things like racism, occasionally police brutality also follows this, that if you control for income, it actually makes it worse, because then you're showing like, well, if you're a different race and you're poor, you still don't get treated the same way. And that is true for this data as well. So you have people who are seeing things in like the outskirts of Oklahoma where they don't make a lot of money. MUFON thinks that they probably saw a UFO, but if you come from a low percentage white zip code, MUFON thinks that you're probably mistaken. And so here's the deal, right? If you think that UFOs exist, there's no reason why UFOs should be more prevalent over white neighborhoods than black neighborhoods. And if you don't think that UFOs exist, then everyone's mistaken in what they're seeing. So there's still no difference between white neighborhoods and black neighborhoods. White neighborhoods and POC neighborhoods, I should say, because we're just looking at percentage white. Anyway, totally cool finding. It's like way more social science than it is UFO, but really cool. And we did it all with data science. Cool result. And I got to talk to these people that are like, oh, UFOs are my life for a while. So that was pretty fun and interesting. Anyway, I developed a new analysis procedure called ROTCore in 2015. It's a visualization and analysis procedure. It uses a lot of the typical tests. It's not like I came up with a whole new test. It's just using the same tests in a different way. Correlation and t-tests. And something called multidimensional scaling, which unfortunately we're not going to talk about much in this class, but it's really useful. So that's something that I created in 2015 and I'm publishing right now. And then I also developed a new contact tracing procedure last year, right when the pandemic started. And it's based in something that we might talk about later called cross-recurrence analysis. Okay, so let's talk about empiricism. Our experience is flawed. Everything that we experience that we think is flawed, and I'll tell you why. Let's skip the second bullet point and jump to the third one. I think the 79 is faster than I-10. The 79, if you're not if you're not familiar with the freeways in Arizona, or highways, I should say, the 79 is the one that connects like the far East Valley to Oro Valley. It's like the back way to go to Tucson. I-10, of course, is the typical way to go to Tucson. I always think the I-79 is faster. But look, I can't be in two places at once, right? So I can take the I-79, or I can take the 79, and I can say, like, it only took an hour and a half. And I know that this one time I took the I-10, it took 2 hours because it was really congested and there was an accident and stuff like that. But I can't be in two places at the same time on that same day, right? I don't know. It might have taken an hour and a half to go the I-10 route. Maybe they're equally as fast. So there's no comparison group with my experience. And then also, there's a day that it only took me an hour to get down there. There was a conference that I was going to. I was late because I wanted to stop for breakfast and I didn't have time, but I stopped for breakfast anyway. You know, so I totally, like, criminal speeding the whole way down. Definitely, like, no one should do that. But I did. Anyway, it was dangerous. You shouldn't speed. I got down there in an hour, and it really stands out in my mind. It only took me an hour that one day. Of course the 79 is faster. There's no way I would have been able to get down there in an hour if I took the I-10. Which is true. I would have been pulled over. There's no way you could go that fast down to Tucson on the I-10. But that's the availability heuristic, right? It's available in my mind. It was a really strong, salient outlier to me, but it was an outlier. It's just one thing. It's the same reason I don't like flying, is, you know, one or two plane crashes that I happen to see, like the MH370 just goes freaking missing, and some of the ones, like when I was a kid, I don't remember where, like in, I think it was in Seattle or something like that, there was a plane crash, and, you know, these are the things that really stand out in my mind, where you will hear people be like, the whole cabin filled with smoke, and then the landing gear wouldn't come down. We had to circle for like 3 hours, and then finally we landed, but we didn't know if we were going to land. This stands out in my mind, and I don't like to fly because of that. It's like all I can think of the entire time while I'm on an airplane. But of course, I don't think about all of the hundreds, if not thousands, of airplane flights per day. Probably hundreds. Thousands seems a lot. But hundreds of airplane flights a day that go just fine. That are totally just fine. And then alternatively, when I think about driving, like, I've never been in an accident, so it doesn't stand out to me as a thing that can happen. But of course we know that driving is the most unsafe way to get somewhere that there can be. So my experience is totally flawed. Like, I live my life not flying and driving, and instead driving places because I think it's safer, but of course it's not. Like, I know it's not, but somehow viscerally I feel like it is. And so now let's jump back to that second bullet point. Empiricism is key. Empiricism is the only way that we can get around our experience. Empiricism is the only way that we can actually see if the 79 is faster than the 10. Also, the 79 takes me past this place called Beyond Bread. And they have really good pretzels. And so there's a little bit of confirmation bias there. If I can say that the 79 is faster, I get to go past Beyond Bread. Which is nice. I like pretzels. They're really good. Anyway, empiricism. So to show you this availability heuristic again, what I want you to do is just look in the very center of the screen. Okay. What was the most prevalent color that you just saw? If you said red or orange or yellow, you're wrong. It's actually blue. If you said blue, you're right. And also, this example only works about half the time. Somehow people really catch on that there's blue. I think it's because my background is not quite the right color. Anyway, it doesn't matter. Sometimes people get fooled by it. And think that yellow is the most prevalent color. The people who do get fooled by it and think that yellow is the most prevalent color, see that because the yellow really stands out against all this other blue. The blue kind of, although not really, because it's a little bit more purple on the M&Ms. And anyway, in a perfect simulation, this would show you that the blue is there, but very close to the color of the background, so it kind of blends in. The yellow really stands out. So does the red. And so people might see yellow as the most prevalent color. They might see red as the most prevalent color, when in reality it's blue. And that's the availability heuristic at play again. What we have available to us in that quick zip by that I did, like that, just shows you just a glimpse, and whatever is more available is the thing that you're going to go with. And some of you got it right, but some of you didn't. Empiricism would have us count all of these individually. You know, one blue, one yellow, another blue, a green. And so it would never be wrong. Empiricism would always give us the right answer. We see this all the time. More obvious pieces of data are more obvious. It doesn't mean they're necessarily representative. We see it in politics, where the loudest, most flamboyant critics of an idea get the most airtime on the news. It doesn't mean that everybody hates something. Video games was a big deal when I was a kid, right? They're too violent. Clearly, those people are not representative of everyone, the people who thought that video games were too violent. But they were really loud. And somehow those people switched parties. Like it's a different party that cares about this now, but they're still loud and annoying. Anyway, the evidence in actual science suggests that video games don't do anything to kids' brains. You can play the most violent video game that you want. You can have whatever's in it. Doesn't matter. Way more important is the interactions that kids get in school and with their parents, not the video games. So whichever or both political parties are going to tell you that, like, oh, video games are dangerous and they're stupid. The sleepwalking defense and insanity defense, those are left over from when this was a talk to the legal group. But if you do know about the sleepwalking defense, you know that it's super salient. Like, we can all, if you do know about it, you know exactly what I'm talking about. Some guy stabbed his wife 40 times and then said, "But I was sleepwalking. I shouldn't go to prison for this," which seems just untrue. How could you sleepwalk through that? Anyway, it's very salient. We think about it, but it's only been used once. I mean, maybe since then somebody's tried it, but it didn't work. Even though it's hardly ever used, it definitely would come up. People would say, like, well, what about the sleepwalking defense? And then lastly, let's talk about bloodletting. So this isn't exactly the availability heuristic. This is just incomplete data. And this is another thing that goes off of sort of experience, but not really. This is more just like collecting incomplete data. So another thing that we want to do with empiricism is we want to always collect complete data sets. You always want to look at what is there, what isn't there, what should be there and isn't. So hits, misses, false alarms, and correct rejections. You want to look at all of it, not just some of it. So for plague in 200 AD, the most effective treatment was bloodletting. And this is all thanks to Galen of Pergamum, who collected all this evidence and said that, well, we should all be bloodletting. It's really good for people. What I'm going to show you in this table here is, of course, not the actual numbers. I've made them round numbers to make it more easy to see what's going on. But it's in the general spirit of what was shown. So Galen of Pergamum ended up collecting data that looked like this. These are the people that lived. If they engaged in bloodletting, 20 lived, and people who did not, who kept their blood inside their body, only 10 of them lived. So yes, it looks like 20 people lived when they let blood and 10 lived when they didn't. So it looks like twice as many people live when they engage in bloodletting, right? So this is what we have. This is the conclusion that we can draw from it. But there is something missing. What do you think is missing? Who died? And the total number of people who did either of these practices. So who died? 80 people who engaged in bloodletting died, and only 40 people who kept their blood died. When you total this up, there's 100 people who bloodlet, and there's 50 people who didn't. There's twice as many people in the first group, and twice as many lived, but also twice as many died. What does this mean? It means there's no effect of bloodletting or keeping your blood. The only effect here is that more people are doing bloodletting than keeping their blood. So yeah, it looks like more people are living here, but really, there's no change. There's no change going on. And people did bloodletting for years, like literally up until the 1800s. Some people were still doing bloodletting. And actually, in really small, weird clinics now, like those strange, you have to go to weird places in South America to get this done, it's still being done. It doesn't do anything. One interesting thing is that somehow bloodletting didn't lead to more deaths with plague. You'd kind of think that if you are using your antibodies to get over plague, that letting some of your blood out would actually harm you. Somehow that didn't happen. But that's kind of neither here nor there. The important thing is a complete data set like this actually shows you what's going on. Maybe we wouldn't have thought that bloodletting was the cure if we had seen the complete data set. Maybe people would have looked for something else. Turns out it's rats. Also, this is kind of pointing us towards central tendency, which is the first thing that we talk about in the class. And that, oh, wait. No, I did. Okay, great. I left in some of my crime data. That's great. Okay. So let's briefly talk about stats. There are two kinds of statistics. There's two questions that you can ask. The first question is there a difference? And the second question you can ask is there a relationship? Let me just make sure that it's in that same order. So is there a difference and is there a relationship? These are the two questions that we can ask. Every statistical test that we have comes from those two questions. Those are the only questions that we can ask, really. I mean, we can ask them in all sorts of different ways, but that's it. It's those two. Is there a difference? Is there a relationship? Let's look at is there a difference. So what you're looking at here is property and violent crime in Arizona, California, Nebraska, and North Dakota. And I wanted to know two things. Is there a difference in rates of property crime between Arizona, California, Nebraska, and North Dakota? I guess I actually want to know three things, sorry. Or four, really. Okay, so I wanted to know four things. I lied to you. The first thing I wanted to know is there a difference in the rates of property crime between Arizona, California, Nebraska, and North Dakota? The second thing is there a difference in the rates of violent crime between those states? The third thing is there a difference in rates between violent crime and property crime? And then the fourth thing is, do those differences change because of each other? Do they interact in any way? And so you can kind of see this from the graph, right? Yeah, there's totally a difference in the rates of these crimes between Arizona, California, Nebraska, and North Dakota. If you're looking at property crime, which is the darker bar, Arizona is tops. This is per capita. By the way, it's not like all property crime. Like California is way bigger than Arizona. And so if Arizona had larger rates of property crime, like overall yearly rates, that would be really bad. This is per capita. This is per person. And you can see that it's like a fraction of a person. So it's like, rates per 1,000. Incidences per 1,000. Anyway, Arizona has more, California a little less, Nebraska a little less, and North Dakota is the least in this set. If you look at violent crime, then there's two states that flip around. California has more violent crime than Arizona, than Nebraska, than North Dakota. So there is a significant difference across states. For property crime, there's a significant difference across states for violent crime. There's a huge effect of crime, though, right? Look at this. I mean, if you look at violent crime, the light bars, compared to property crime, the dark bars, there is far, far more property crime than there is violent crime. And really, that's great. I'd rather have something stolen from me than get murdered. And then lastly, there is a significant interaction. What that means is that these things differ when you look at one group of bars compared to another. So if we look just at Arizona, yes, there is a difference between property crime and violence. Quite a large difference. If you look at California, there's a smaller difference. They have less property crime and more violent crime. So that's not so great for you, California. And then actually, when you look at Nebraska and North Dakota is pretty low on property crime, and they're also low in their violent crime. But the proportion between them is really similar to California's. So North Dakota is kind of a violent place. Illogically. Somehow Arizona and Nebraska are less violent. But you'll get your bike stolen in Arizona like all the time, apparently. All right. So that's the question of, is there a difference? Well, now let's look at, is there a relationship? What we want to look at here is, do property crimes and violent crimes significantly correlate? So instead of looking at this is data for 1 decade. Here we're looking over the course of 60 years. So I've got data for 60 years here. This is just for Arizona. And we've got property crime on this axis, and we've got violent crime on this axis, and we want to know, is there a relationship between the two? So as one grows, does the other one grow? And you can look at the line right here, the best fit line, and you can see like, yeah, man, as it becomes more property crime, there becomes more violent crime. Or the other way. It's a correlation. You can't really say which one is pushing the other. You can just say that there's a relationship between the two. And it's a pretty strong relationship. It's a correlation of 0.8, and it's significant. You can tell because it's less than 0.05. This is actually less than 0.001. So this is a significant relationship between property crime and violent crime. The other thing is, when you look at Arizona over the last 60 years, we've grown a lot. California's grown too, but there were a lot of people in California 60 years ago. Arizona was like a wasteland 60 years ago, and now Phoenix is one of the largest metro areas in the country. So likely this growth is pushed by people. More people come and more people do crimes. Okay. That is the last thing we are talking about. In a nutshell, that's empiricism, why we need empiricism, why we actually have to look at things and not rely on our own experience. The two main questions that you can answer with statistics: is there a difference? Is there a relationship? The last thing that I didn't mention, sorry, let's go back to this. Right here. So you all have careers that you like, the careers that you think that you're going to like when you get into them. And you might. And if you do, that's amazing. But as you go through your schooling, if you figure out that this isn't for you, what you're planning on doing isn't for you, if this class, this biostatistics class that most of you are just taking because it's a gate to get into what you actually want to go to, right? You have to pass it before you go on. If you like it, if it becomes something you really like, maybe you should consider a career in data science. You'll have to learn more about statistics, but if you like this class, you'll probably like the higher stats classes as well. And data science is one of the hottest careers according to Forbes. More data scientists are being hired by more companies than ever before. When Obama was in office, he started opened the position, the very first data scientist of the United States, the chief data scientist of the United States, is a position that he created. Of course, that was creamed 4 years ago, but I expect it's going to come back soon. So at a company level, at a national level, hopefully soon at local levels, we'll also see data scientists coming into play roles and things. Data science is like where it's at. And really, if you think about it, if the only way that we can learn things is through empiricism, and then the only way that we can figure out what the empirical research is telling us is with data science, then of course we need data scientists. Of course we need empiricists. And that's the only way that we can learn actual truths and progress as a society or as a company or as whatever it is that you're working for, as a science, as a profession, any of that. So of course we need data scientists. If you can inject that into your future career, this knowledge of like, we need empiricism. Let's say exercise science. What workout program is really the best? Test it out. Use data science. Then you'll really know that you're helping your clients. It's true for all the professions. So hopefully you enjoy this class. Hopefully you at least take away from it that if you forget how to do the data science, you need to talk to somebody who can to help you make your profession even better. Anyway, good luck in the class. Of course, I'll see you throughout the rest of this semester. So if you have any questions about the research I've done, questions about data science, statistics, whatever, feel free to ask me, your TAs, anybody. All right. Talk to you later.